ladies and gentlemen. Notes 5.2 are on trigonometric ratios for special triangles. So I'm going to show you guys something on the next page of my software. You don't have to draw this out until I come to this section and draw stuff out, but I do want you guys to pay attention to this because it's the foundation for what we're going to talk about in today's video. So if you notice right here, I have a right triangle here, and it is an isosceles right triangle. So I know it's right because I would have had that right angle box inside of here, and then this is isosceles because I'm telling you guys it's isosceles, okay? And if I tell you that one side of my triangle is 1, has a length of 1, then the other side of my triangle also will have a length of 1. So I want to figure out what the length of my hypotenuse is going to be. So I'm going to do a squared plus b squared equals c squared. And I'm going to do 1 squared plus 1 squared equals c squared. So 1 plus 1 is equal to c squared, so 2 equals c squared. Now to solve for c, I'm going to square root both sides. So c is equal to the square root of 2. Okay? So that means that when I have an isosceles triangle here, if one side is 1, the other side is 1, the last side is going to be root 2. That's always going to be the relationship. Now, because I have an isosceles triangle here, since this side is congruent to this side, then this angle up here has to be congruent to this angle down here. And since the angles in a triangle add up to 180 degrees, and this one is already 90 degrees, then I can figure out the missing angles here by taking 180, subtracting 90, and then divide it by 2 because the angles are going to be congruent to each other. So I know that there's 90 degrees left to split between these two angles. Divided by 2, I've got a 45-degree angle here. Okay, and they're both 45 because it's an isosceles triangle. Okay, awesome. So this means that the first type of special triangle that we're going to look at is a triangle that's a 45, 45, 90-degree triangle. Okay, so for the 45, 45, 90-degree triangle, let's go ahead and draw this in. This time I do want you guys to draw this information in. So I'm going to draw my right triangle right here, where all my sides, not all of my sides, 2 of my sides are going to be congruent to each other. Okay, so we will put right here that this is congruent to this. It's a right angle. We said that this side is 1, this side is 1, and this side is root 2. Okay, so now let's talk about our special triangles for a different set of degrees. Okay, now I want to look and see what happens if I have an equilateral triangle here. So if I have an equilateral triangle, that means that all of my sides are congruent, and it also means that all of my angles here are 60 degrees. Okay, so I don't want to look at a 60-degree triangle with 3 60-degree angles. I still want to look at a right triangle. So what I'm going to do is I'm going to draw an altitude right here, and I'm going to cut this triangle in half right here. So now I have 2 separate triangles, and because I have an altitude and it was an equilateral triangle, I get 2 right angles, and this side is congruent to this side. Okay, now I want to say that this side right here is 2, which means that this side is 2, which means that this full length here is 2. If that's the case, then this side here by itself is just 1. So what I end up getting right here is a new triangle that's right, where this side is 1, this side is 2. I know this is 60 degrees, which means this has to be 30 degrees for 2 reasons. A, because the angles in a triangle should add up to 180, and B, because I cut the angle in half right here. So now I want to figure out what this B value is going to be here. So I'm going to use Pythagorean theorem. So I'm going to say 1 squared plus b squared equals 2 squared. Well, 1 squared is 1, b squared is just b squared, and 2 squared is 4. Subtract the 1 from both sides, and I get b squared equals 3. So then I'm going to square root both sides, which means b is equal to the square root of 3. So here I know b is the square root of 3. I'm going to go ahead and draw that into my notes right here. That's my second type of special triangle. So that triangle, instead of being called a 45, 45, 90 triangle, we'll call it a 30, 60, 90 triangle. So when I draw my triangle out, it's going to look as follows right here. So this is 60 degrees, this is 30 degrees, this is going to be 1 right here, this is going to be 2, and this right here is the square root of 3. Okay, so when I'm doing this part right here, the next thing I want to do is I want to calculate the trigonometric ratios for these special triangles that we have. So I'm going to write out on the side right here this, the SOHCAHTOA thing to help us remember what it is that we're looking for. So if sine is opposite over hypotenuse right here, then sine of 45, and I'm sorry, let's add in that these are 45-degree angles, and we'll put the 45-degree angle here. We'll use this one. It doesn't matter because it'll still give you the same ratio. But since sine is opposite over hypotenuse, I'm going to do 1, which is opposite over the hypotenuse, which is the square root of 2. But remember how we talked about the fact that we need to rationalize the denominator. So I'm going to multiply by root 2 over root 2 to get the square roots to cancel out. So I end up getting root 2 over 2. So the sine of 45 is always going to be root 2 over 2. And I want to write down approximately how much that's going to be. So when I type this into my calculator, I'm going to do 2 square rooted and then divide that by 2, and I get approximately 0.707. So we can say that this is approximately 0.707. Okay, so now to find the cosine of 45, this time I'm going to do the adjacent over the hypotenuse, so it's still going to be 1 over root 2. Same exact process. When I rationalize the denominator, I get root 2 over 2, which is still going to be approximately 0.707. Okay, now to find the tangent of 45, I would do the opposite over the adjacent, so I would do 1 over 1, which is simply 1. Okay, to do the cosecant of 45, the cosecant is the opposite of sine, so it's the reciprocal of sine. So here what I'm going to do is I'm going to do the hypotenuse over the opposite. So the hypotenuse right here is root 2, and then the opposite is 1, so it's root 2 over 1, which is simply root 2. So I get root 2 right here. And I want to calculate how much that is approximately. So I'm going to take 2 and square root it, and I get about 1.414. So we'll say this is approximately 1.414. Okay, to find the secant of 45, same thing, except I'm going to do the hypotenuse over the adjacent. So I'm going to do 1 over root 2, root 2 over 1, so it's going to look like this. So I get root 2 again, which is approximately 1.414. Okay, and then lastly, we've got the cotangent of 45, and since tangent is opposite over adjacent, we're going to do adjacent over opposite, so it'd be 1 over 1, which is 1. Okay? Okay, so to do sine of 30, we're going to look at 30 degrees now. I'm going to see that this is the angle that I'm looking for, and across from the 30-degree angle is 1, so this is going to be the opposite. Next to the 30-degree angle is root 3, so this is going to be the adjacent, and this is always going to be the hypotenuse. So to find sine of 30 degrees, I need to do opposite over hypotenuse, which is just simply 1 over 2, which divides out to give me 0.5. To do adjacent, to do cosine of 30, I need to do the adjacent over the hypotenuse, so I'm going to do root 3 over 2, and then I'm going to type that into my calculator. So I'm going to take 3, square root it, divide it by 2, and I end up getting approximately 0.866. So we'll say this is 0.866 right here. To find the tangent of 30 degrees, I would do opposite over adjacent. So now when I'm doing this right here, I'm going to do 1 over root 3. Now, to do this, I need to rationalize my denominator. So I'm going to multiply by root 3 over root 3, and I end up getting root 3 over 3 because the square roots cancel out. So the tangent of 30 degrees is always going to be root 3 over 3, which is approximately, so I'm going to take 3, square root it, divide it by 3, and I end up getting approximately 0.577. So here I get 0.577. Okay, awesome. Now for cosecant of 30, I need to do, instead of opposite over hypotenuse, I need to do the hypotenuse over opposite. So it would just be 2 over 1, or simply 2. Okay, now to do the secant of 30, I need to do the, instead of adjacent over hypotenuse, I'm going to do hypotenuse over adjacent. So I'm going to do 2 over root 3. But to rationalize the denominator, I need to multiply by root 3 over 3. So I end up getting 2 root 3 over, these roots will cancel each other out, so I just get 3. So the secant of 30 is 2 root 3 over 3. And I'm going to figure out approximately how much that's going to be. So, so I'm going to have 2 times 3 square root it, divide that by 3, and I get approximately 1.155. Okay? Now to do cotangent of 30, I need to do, instead of opposite over adjacent, I'm going to do adjacent over opposite. So the adjacent is root 3, the opposite is 1. So I'm going to have root 3 over 1, which is just root 3, which is approximately equal to, so we'll just take 3, square root it, we get 1.732. Okay, so that's for 30 degrees. Now let's do the same thing for 60 degrees. So this time, this is the angle that I'm looking at, which means that the root 3 is now the opposite and the 1 is now the adjacent, but the 2 is still the hypotenuse. So to find sine of 60, I need to do opposite over hypotenuse, which is going to be root 3 over 2, and we figured out already that root 3 over 2 is approximately 0.866. To do cosine of 60, I need to do adjacent over hypotenuse, so I would do 1 over 2, and I would get 0.5. To do tangent of 60, I would need to do the opposite over the adjacent, which is root 3 over 1, or just root 3, and we figured out already that that's approximately 1.732. 60. Instead of doing opposite over hypotenuse, I want to do hypotenuse over opposite, so I would do 2 over root 3, which we did the work on the side here already to rationalize the denominator. Multiplied by root 3 over root 3, we get 2 root 3 over 3, which we figured out is approximately 1.155. Okay? Now, for secant of 60, I want to do the opposite, I want to do the hypotenuse over the adjacent. So I would do 2 over 1, which is just 2. And then lastly, for cotangent of 60, I want to do adjacent over opposite. So I would do 1 over root 3. And then we multiplied by root 3 over root 3 to rationalize the denominator. So we get root 3 over 3, which we figured out is approximately 0.577. Now, if you notice, there's a lot of relationships between 30 and 60 degree trigonometric ratios. Think about those relationships, and we'll talk about it next time we have class together. So now we're going to use our information to answer these questions here. So determine the exact values, so no rounded answers, of the expressions below. So the first one is sine of 45. Well, we know sine of 45 is root 2 over 2. So I'm going to do root 2 over 2. And we also know that cosine of 45 is also root 2 over 2. So root 2 over 2 times root 2 over 2 plus. Then I'm going to go to sine, and I know that sine of 30 is 1/2. And then I'm going to do sine of 60, and I know that sine of 60 is root 3 over 2. So now when I multiply these guys together, root 2 times root 2 is 2, and then 2 times 2 down here without the square roots is 4, plus 1 times root 3 is root 3 over 4. They have a common denominator, so I'm just going to say my final answer is 2 plus root 3 all over 4. Okay, now for sine of 60, I'm going to do the same thing. I'm going to use my information here. So sine of 60 is root 3 over 2. Cosine of 60 is 1/2, plus sine of 30 is 1/2, and then cosine of 30 is root 3 over 2. So here I end up getting root 3 times 1 is just root 3. 2 times 2 is 4. I'm going to do it again. Root 3 times 1 is just root 3. 2 times 2 is 4. So I end up getting 2 root 3 over 4, but I'm allowed to simplify this to make this a 1 and make this a 2, so I end up getting just root 3 over 2, and that's my exact answer. If you have any questions, let me know. I hope you have a great day. I will see you later. Bye.